Hello, Jim. This is a video demonstration about your issue on the Watchdog timer. So I summarized the issue into three items. First is the Watchdog timer itself. Second is the Watchdog timer timeout, and last is the debugging when Watchdog timer is turned on. Okay, so with regards to the operation of the Watchdog timer. So I found out that in your code, you are using the Archon bits that software watchdog timer enable is turned on here. Okay, so this is the part of the code that makes you look that the watchdog timer is working unusually. Okay, so I'll try to demonstrate it in this video. Okay, so first, let's try to turn off the watchdog timer. So I'm going to place a comment here so that watchdog timer is turned off, and then program the code. Okay, program complete. So as you can see, if I use a logic analyzer to monitor RA1, as you can see, there is a periodic toggle of RA1, which means even though the watchdog timer is turned off, it is turned on. The reason for this is because when watchdog timer is turned off in the configuration bits, it can be software controlled by using the SWDTN bit here. Okay, so if I'm going to turn off the watchdog timer, sorry, the Archon bits here and program, we were able to see that there will be no watchdog timer timeout. Okay, so let's check. So as you can see, there is no, the RA1 does not toggle at all. That means the code is not being reset because there's no watchdog timer timeout. Okay, so and of course when we turn on the watchdog timer in the configuration bits, there will be a timeout regarding if we set or clear the software watchdog timer enable. Okay, so let's check. So as you can see, there's a periodic timeout here. So there's a pulse which high, the pulse with high is 0.994 seconds, and the low pulse is 0.29 seconds. Okay, so the next part is I'm going to demonstrate about the Watchdog timer timeout. So as you can see here, there's a 0.29 seconds that the device or the RA0 is turned on. Okay, so in your code, I found a defines which is Watchdog timer period test. So I would assume this is the part of your code wherein you are trying to measure the Watchdog timer. So you put a while one here because if the code goes in your infinite loop, there is a several clear Watchdog timer there that would eventually clear the Watchdog timer and prevent the Watchdog timer to timeout. Okay. So using your settings in the configuration which is um, PS 1024 and prescaler of 32. So we expect that the timeout would be 1 second. And in the waveform, as you can see here, it looks like the timeout is about 0.994 plus this 0.29 seconds. Okay, so when I change this post scaler, let's say we change this one to 512 in program. So with this configuration, what what I expect is about zero point 0.5 seconds timeout. And we'll check the result using the logic analyzer. Okay, so let's check. Okay, as you can see, there is a pulse here, a square wave. The pulse with high or the duration of the pulse with high is about zero point 0.5 seconds, which is about consistent with the timeout. But as you can see, there is a 0.29 seconds, which is wherein the pulse width is low. This is actually consistent with the one that we got earlier. So what I am confused about is where is this 0.29 seconds coming from? Okay, so what I did is that so you're checking the period here. So what I did is I added this code. So this one. And basically this one is the configuration of the clock and the port that we use to monitor the watchdog timeout. Okay. So I assume that there's something in the sysboard init function that makes it uh, last long. That's why there's a 0.29 seconds delay. Okay, so I will enable that by placing a comment on this default code. Okay, by doing that, okay, and let's try to bring back the configuration back to 1 second timeout. Okay, so let's try to check the timeout. Okay, so as you can see here, the timeout is now at 0.9929 seconds, and the delay that I was talking about was minimized to about zero point 0.7 microseconds. Okay, so this is the timeout. So if we bring back this one to PS 512, so what we expect is there will be 0 0.5 seconds timeout. Okay, so let's check. So there's your zero point 0.5 seconds timeout. Okay, so we're done with the timeout. So the next thing is about debugging with Watchdog timer enabled. So I am aware that before there is a warning that the IDE is bringing out when the Watchdog timer is enabled, and then you debug the code. So for some reason it does not show here, and in order for the debug mode to be consistent with the release mode, I changed the clock settings of the realize to about 20 MIPS, which is the same as the one that you are using in your code. Okay, and if we okay, so let's check. Okay, so the watchdog timer is enabled and try to debug. Okay, so we're in the debug mode. So if we're going to push play, so as you can see, the program counters goes to 0 because there's a watchdog timer timeout. This is being we have demonstrated this during our call. Okay, and when I push play again, you will see that this breakpoint will be hit. Okay, meaning it resets and then goes back and breaks here. Okay, so basically the watchdog timer is working, that's why it resets and it breaks here. Okay, so I need to check this out with the software development team if the watchdog timer is really working on the debug mode, but basically based from this demonstration it works. Okay, so Jim, that's all for now. Bye.